Hello, good day everyone. So today we're going to continue with module 11, which is timer. So in this chapter, we're going to learn about the programming timers 0, timers 1 and also timers 2. So what are the difference between these three timers, okay, as well as the counter. So for the introduction part, okay, so in microprocessor, we can use the counter registers to count an event or to generate time delays. For example, if we want to count an event, we connect external source to the clock pin of the registers. Okay, so we need to have additional source, or the additional source may refer to the switch. Okay, for example, we want to say that once the switch is pressed by 1, the counter will be count by 1. Okay, so if we press the switch by 2 times, it increment the it is incremented by 2, so we want to count. Okay, and if we want to generate the time delays, we need to connect the oscillator, okay, to the clock pin. So you have the microprocessors, okay, so either you connect it with the source, okay, source, or for example you have a switch, or you connect it to the oscillator, okay, oscillator for time. Okay, so this is for time and this is for to count. Okay, so you need to know what you want to do. Okay, either you want to count or you want to create the time delay, and then you need to make sure that the connection is correct. Okay, make sure you connect it to the clock pin. Okay, so this is the clock pin. So either you connect with the external source or you connect with the oscillator to make either it is time delay or counter. So the contents of the counter registers will represent how many ticks, okay, the event occur from time to time we clear the counter. So when the count is completed, the flag will be set. Okay, set means 1. Alright, next, in order to create the time delays, okay, so here we know that we can create the count or create the time delays. So if you want to create the time delays, okay, there is two methods. The first and second method. The first method is CTC, or clear the counter, or the other name is compare mesh. So if you read this through the Google or books, okay, there are the first method. So the second method is overflow method. Okay, so what are the difference? So for the first method, actually it is to clear, okay, is to clear the counter at the start time and wait, okay, at the start time and wait until the counter reach a certain number. So you know, for example, you know that a certain numbers for the time delays that you require is 100, okay, 100, and then the counter, okay, the counter will only be cleared, okay, at the start time and wait until the counter reach a certain number. So if your microprocessor speed is 1 megahertz, okay, and then you want to count until 100, so here we have t, we know this equation, the time, the duration, the t the capital T will equals to 1 over F. So 1 over F is 1 over 1 megahertz. So the time, okay, the time from one signal to the second signal, or from one tick to the second tick, is only 1 over 1 mega is 1 microsecond. Okay, so if you are using CTC method, the certain numbers for this case is 100. Okay, so 1 microsecond will be count, okay, will be count until 100 times. So 100 times is equivalent to 100 microsecond. Okay, so after a certain number, okay, the counter, okay, the counter will be cleared. Okay, this is for the first method. And the second method, okay, and the second method is overflow, where you load, okay, you load the counter registers and wait until the counter overflow. Okay, you wait until the counter overflow and the flag is set. Set means 1, overflow means you refer to the overflow flag. Okay, you refer to the overflow flag. So this is the second method. So for example, you have a microprocessor speed of 1 megahertz, and then you have 8-bit counter registers. Okay, so if you want to create a time delay of 3 microseconds, okay, you want it to have 3 microseconds. So here you know that your time will be equals to 1 over 1 megahertz, which is 1 microsecond. So in order for you to have a time delay, okay, a time delay of 3 microseconds, means that your microprocessor must be count or ticks, okay, must be count or ticks by, okay, by 3. Why by 3? Because you want to have it 3 microsecond. So you know that the time that produced by your microprocessor speed is 1 microsecond. So in order for you to have a time delay of 3 microsecond, you need to have the count, okay, the count, which is increased by 3 times, so that you have from 1 microsecond you can get the time delay of 3 microsecond. Okay, so the first how this happen is you need to load the counter register with FD and wait until the flag is set after 3 ticks. So the first tick, okay, we know that the counter will be incremented 1 by 1, right? So once it because this is 8-bit, so you have this one. So once you have the first tick, okay, the first tick, the content will be increased by 1. So for example, if you load your counter register with FD, so if increase by 1, you will get, okay, increase by 1, you will get FE, and then increase by another 1, you will get FF, and then increase by another 1. Okay, we know that for 8-bit registers, okay, the highest content is FF. Okay, the highest content is FF. So once the third tick, okay, the third ticks, the content of your counter registers is overflow. Okay, is overflow. So this happen because you are using the second method, okay, in order to get the overflow flag to be 1. Okay, So that is the way or the method to generate the time delay. You can use the clear the counter method, or you can use the overflow method. Okay, next we move to programming timers 0, timers 1, and also timers 2.